Hi guys, so in this video we're going to be discussing our mini project. So for our mini project, we were tasked with predicting the number of deaths in 2011 for all U.S. fatal accidents. We're going to show the various methods we use in R to arrive at our final number and describe in detail how each step works. So the data we use in our model construction dates from the years 2000 to 2010. It contains information of the different elements and factors related to car accidents throughout the U.S. Some of the variables included are age, sex, state, seat position, alcohol use, and more. All of these factors can contribute to whether or not the accident resulted in any fatalities. However, some variables are more important than others. The variables we decided to drop because of lack of information gained are latitude, longitude, county, day, hour, and minute. We dropped state case, person number, and vehicle number since they are unique to a specific case. We also dropped seat position, person type, and owner since they had too many non-numeric values that we could not easily recode. On the other hand, the variables we did include were injury severity, drinking, day of week, travel speed, route, state, and more. We also took the non-numeric variables we kept in the dataset, such as injury severity and drinking, and recoded them so they would be numeric values, thus allowing us to run our model effectively.
In the statistical program R, we use two models to calculate our predictions. There are the generalized linear model, known as GLM, and a linear model. A GLM and a linear model's purpose are to investigate the relationships between the response or dependent variable with one or more predictor or independent variables. Generalized linear models and linear models can only take numeric variables, so any categorical variables that you want to include must be recoded into dummy variables before they can be run. For our project, we decided to use a GLM to calculate our final predictions. While we did create a good linear model, it did not perform as well as our GLM when it came to our cross-validations. For our GLM and linear model, we used the variables sex, route, state, and drinking from the years 2001 to 2008 because they were found to be highly significant.
Cross-validation is a method for testing if a model is a good predictor of future unknown data. How it works is that currently known data is split into training data and testing data. The model is then built on the training data and tested against the testing data. This would be an example of a twofold cross-validation, but it is recommended for you to do at least 4 to 5 for the best results. To do this, you would repeat the process explained above several times over swapping out portions of the training data for the testing data each time until all of the training data has been used as the testing data once. The predictions are then summed and checked against the actual values with the hope the predictions are all close to 100%. For our project, we used the data from years 2001 to 2008. So, for each year, we would use the data from all other years to predict the outcome in the missing year. For example, to predict 2001, we would use the data from 2002 to 2008. We then combined all the different predictions and exported it from R into an Excel file. We then summed the values of the injury severity column to create an overall actual number of deaths throughout the year. Next, you do the same for the predicted values to create an expected number of deaths. The actual deaths are then divided by the expected deaths to provide a measure of how good our prediction is. A value under 100% means we overpredicted, while a value over 100% means we underpredicted. In our model, the actual number of deaths was 335,821, while expected was 335,873, giving us an actual over expected ratio of 99.98%. This means our model was 99.98% accurate in correctly predicting whether an accident will have a fatality or not. We then did this over for each specific variable. The first one was state. We first performed it on California because it was one of the most significant state factors. We ended up with 32,390 actual deaths and 32,390 expected, with a ratio of 100%. We then did this for every state and got promising results like 99.96% for Michigan and 99.98% for Colorado. The worst prediction was from Rhode Island at 99.86%, showing our model performs very well for every state. Next, we cross-validated for sex. For males, it was 233,354 actual and 233,400 expected, with an actual over expected ratio of 99.98%. For females, it was 102,395 actual and 102,401 expected, with an actual over expected ratio of 99.99%. Next was for route with the categories of U.S. highway, county road, interstate, state highway, and local street. Finally, we cross-validated for if drinking was reported or not, since alcohol was a significant factor in determining if an accident happened or not.
After we finished our cross-validation on our GLM model, we ran it on the 2011 car accident fatality data and came up with a final predicted value of 31,628 fatalities for 2011 car accidents. By sex, we predicted 22,007 male fatalities and 9,614 female fatalities. For alcohol, it was 5,304 involving alcohol and 26,324 not involving alcohol fatalities. For state, it was Texas at the highest fatalities with 2,963 and Vermont at the lowest with 46. And then finally for route, the highest was state highway at 8,926 fatalities with the lowest in township.